we're going to have people in Slack channel, or is there anything I should be monitoring, or do you want to field questions?
I'll monitor the Slack channel. We just went live, so
Cool.
yeah, there's a thread in DS Basic Prep, and we'll go there. Or
Thanks.
I'll keep an eye on it, so we're good.
Cool. Yeah, relay any important questions. All right. Shall I get to it then?
Yeah. Hey everybody, this is our Galvanize study hall. I have Clark in here today. I couldn't get my pass-through audio to work very well, so we'll be hearing him from the output speakers from my computer into this microphone. Please let me know if his voice is very muffled. I can hear it very clearly, so I think it'll likely be good enough. And he's going to show some stuff with VS Code, with Visual Studio Code, and then we're going to jump over to Replit to do some pair coding, because we actually ran into this quirky issue with VS Code that I tried to troubleshoot a few weeks ago, where if you run Ubuntu or Xubuntu in a virtual machine, VS Code can't really work in that space. And so VS Code in a virtual machine generally fails, and I haven't gotten it to work yet, which is pretty frustrating, to be honest. I'd really like to get it to work so that I can demo, so both of us can demo Linux stuff without needing a native Linux box running Ubuntu. Hopefully we'll find a fix for that. But for the time being, we're not going to be demoing pair coding with VS Code from a virtual box. Instead, we'll just do some pair coding in Replit, which will hopefully be helpful to some of you, and then we'll demonstrate pair coding with VS Code at a later time. That's kind of the long story, I guess, a long and short story. So Clark, feel free.
Okay, cool. First, just want to do a little audio check. Can people hear me okay? Toby, you have to let me know.
Sure. Yeah, give a thumbs up in the Slack if his voice is coming through okay. And Clark, keep talking.
Okay, right. That would make sense. All right. Hey, everybody. My name is Clark, and I am an instructor for the Premium Prep, as well as I do the interviews. A lot of you all who are going to be interviewing for the DSI will be interviewing with me, or one of the other interviewers. So, I'm around to help people with Python and help teach the Premium Prep classes as well. Cool. All right. So what I want this to be is sort of a general overview of, I've had a lot of people kind of asking, it seems like there's some confusion about like what this tool is, what Visual Studio Code is, and why it's useful, how it's useful. So for those of you, it's similar to Replit. So let's just juxtapose this against Replit real quick. Get my REPLs open. So REPL stands for read, evaluate, print, loop. It's kind of less important what it stands for and more important it's more of a word than an acronym, if anything. It just means a complete enough coding environment, something where you can write code and run it in a complete fashion. So probably most of you are familiar with this. I'll just demo this. I'll do print, hello, and I'm gonna hit this run button up here, and then you'll know it's gonna run on the right-hand side here. So now back over to the S code, excuse me. All right, so the way I use this might be a little bit different from the way you're going to use this. I wanted to show like a whole setup process. This is probably looks a bit different than what you all are seeing, but I assure you this is regular Microsoft VS Code. I'm running Linux, so I won't be able to give you OS specific stuff outside of what is relevant to me on my computer. So I won't be covering shortcuts or things like that. You'll notice this bar on the left-hand side is not present. You all will have that bar on the left-hand side. I installed an extension to put all those buttons right down here in the bottom left, so they're all pretty condensed. That's just a visual thing that's a personal preference for me. But this is what you will be using. Another difference that you'll notice is this section here, the terminal. This is my command prompt. This is the same as this. For those of you running a Mac, your terminal will work very similarly to the way mine will work in Linux. So this is your iTerm or iTerm2 or whatever you use. So that's what's going on in this bottom section, even though it looks a little different, that's what's happening here. So the way I prefer to work is I like to have my editor. I prefer it on the top. You can have it on the right, or you could have it on the left-hand side, although for some reason I never see that. Generally it's on the bottom or on the right-hand side. But we could put this wherever you wanted. I can't drag it like I can in Atom. I usually use Atom. That's my day-to-day editor. But anyways, I'll just leave it on the bottom for now. Okay, cool. So I showed how to do just a simple print, just write a little code and run it in Replit. So let's do that. So there's a couple more steps here. What I want this to be a file, where I'm writing the code, I want it to be a file on my computer, just an actual file. So there's a couple ways to do it. It's like 2 pages overlapping. It'll be up in the top on that left-hand bar. It'll be the very top button. So you can come in here, and if you want to do it graphically, you can, let's see, I rarely use this anymore. I use the terminal, so I'm having to navigate a little bit. So we'll say Untitled Workspace, language.py. Okay, so let's add a new folder. Actually, let's add a folder, add an existing folder to our workspace. Okay, so I'll come into my home directory. And we'll do, where is it? Here, programming projects. So I'm just going to select this. This is a folder that I made. You can make whatever your own projects directory. Call it whatever you like. I'm just calling mine programming projects just because. All right, so we can see there's actually nothing in this folder. I'm going to come up here. I'm going to click this new file button, or I can right click. Nope, that's in Atom. You can't right click in VS Code. So I'll have this selected. I'll hit new file. And then whenever I start a new project, the convention is like your main file. That's going to be your primary entry point for your project is going to be called main.py. So I'll call it main.py. And we'll start with that one.
Really quick, Clark.
Yep.
Can you increase the size of the font?
Yeah, okay.
Just a little bit. Maybe just a couple clicks. Yeah, that's
Is that
awesome.
better?
That's great, yeah.
Okay, we can even go one. Let's get it nice and big, just so we're like nice and focused in. All right, that's plenty. Yeah, that's better. You can probably actually even see these icons down here now. Okay, good. So we have main.py. Okay, so this tells me that I'm editing the file called main.py, right? And we'll just start our program right here. We'll do print, hello world. Okay. All right, so when this file is not saved, it's gonna have this little white bubble right here. It's important to pay attention to that. My eye just kind of automatically goes there anymore because a lot of times you'll be trying to run your code in a file that isn't saved, and it's going to be running the file that's like in your that's saved on your hard drive, not the file in the state that it is in VS Code. So I have to save it. For me, that's just Control S. I think that's what it is on Windows. I believe it's Command S on Mac. So I'm going to save that file. Then what I like to do is I like to execute my code directly in my terminal. Now, your prompt will look different. This is a customized ZSH shell prompt, and that's what I like, but your prompt will look different. The commands are going to be all the same. So if I want to execute that file, I'm going to say IPython 3. For me, I have to put the 3 there. I know some people don't have to, but I do. So your command may differ slightly. If IPython 3 doesn't work, try just IPython. We'll do IPython 3, and then I'm going to do main.py. I suppose, yeah, we'll just run that for now. Okay, so this says hello world. I realize that there may be sort of a disconnect, like how does it know that I'm talking about this particular file? The name of the folder that I'm in is programming projects in VS Code in here, right, where that file is. I'm presuming some prior knowledge of the terminal with this, but just to demonstrate this quickly, I'm going to do a command called print working directory. The command is just pwd for print working directory. And this will show me my absolute path. So from my root folder to my home directory, to my name, my username, which is just me, to the folder that I'm in, programming project. I can change this directory, so I can do there's a command called cd, right? So the directory that I'm in is nested within other ones. If I want to go up to the parent directory, I can do cd .. and that'll take me to my home folder. If I want to go back, I can do cd and then the name of the folder that I want to go into. I'll say programming, and I have an autocomplete. And just hit tab there. Okay. So now that I'm in here, I can just tell it which file I want to run. It's like IPython 3, and that's how it knows which file to run. So this is the way that I prefer to work. I actually don't even, to be honest, like I don't like managing my files in here. Some of you will hear me say that I'm dyslexic, and I'm not kidding about that. If I get like more than 6 or 10 or like 20 files, and I'm trying to like change between them fairly quickly or find stuff fairly quickly, like it's kind of hard to like parse through that whole thing. I find, I know a lot of people love that visual file finder, and for some people they have a hard time getting the terminal commands working. So it's there. You can navigate your files in here. You can create new files. I could delete this file. I can select the files that I want to select. So this tool is up to the task, but it's not my personal preference. And if you want to use it, that's fine. I will encourage those of you who feel ready to start diving into your terminal more, just collapse that and do all your file management through your terminal. And that's what I do. So let's try to simulate the functionality of that in the terminal. The first thing, obviously, that I want to do is know how do I change to which directory, which I just showed, right? I can hit CD, which stands for change directory, and I can select the directory that I want to go into. If I want to go up into the parent directory, I can just do .. / until I go up to the directory that I want to get into. But I'm in the directory that I want, so we're there. If I want to create, let's say I want to see what files and folders are in the current directory that I'm in, I can use ls, or just L for me also works. So ls or L stands for list, and that'll show me all the contents of this folder. So we can see the simple view is just ls. And we can see main.py. Let's say I want to create another folder here, or another file. We'll call it lib.py for library. So the way you create another one is you do touch, touch, and then the name of the file you want to create. So this would be lib.py. Okay. Notice it didn't show me anything, didn't do anything. So if I want to see it, I have to ls. All right, so now I have a file called lib.py. So it exists. Now I want to open it in VS Code. I'll do code. Wait. Oh, it is code. Okay. Lib.py. Cool. All right, so the command for VS Code is code, which is, that's the thing that it is. I have my feelings about it, but it's just called code. So for most of you, it'll be that. Your command may vary depending on your operating system and the version of VS Code that you have installed.
Yeah. It's a little presumptuous, right? That Microsoft is like, let's just call it code.
Yeah.
Because
I wasn't going to say anything, but since you did, Tovio, I find it quite presumptuous indeed to say, oh, well, if you want to code, obviously you should use VS Code.
Yeah. It's cool. Right? It's cool. I mean, I like VS Code, but, I prefer Vim, and I use VS Code because it's pretty standard at Galvanize, and it's good. It's a good text editor.
It is.
So is Atom. So is Text Wrangler. So is Sublime Text. I actually like VS Code more than all those, but, Vim all day. Anyway.
Yeah, if I were a Vim lord like Tovio, I would also Vimify my life. Am I doing it right, Tovio?
I don't know.
Can I please be in the cool programmers club now?
I mean, the thing is, if you use Vim, you never talk about it. Except I just did, so I don't know.
Right. Yeah, that's the first rule of Vim: is you never talk about Vim.
Unless you're arguing
Vim is super
about
cool. I haven't learned it yet, but I do actually prefer Atom. That is my preferred text editor. But like Tovio said, VS Code is great. It's very standard throughout the industry here at Galvanize, and it's the text editor that we recommend. Even though my personal preference is Atom, I will recommend that you install VS Code because that's where the industry is at. I get by fine in Atom, but that's because I'm determined to do so. So anyways. Cool. So yeah, the presumptuous word of usage to use VS Code in your terminal is just code. So that's how we'll open a project. So, all right, let's do something. Let's, so what do I want to do? I want to write a function in here. I want to build like a little tiny mini project. So I'm going to follow convention. And this is less about the code that I'm writing and more about just demonstrating a small but complete project, complete in the sense that it has sort of the parts to make a sort of conventional Python project. So we have our main, which is going to be our entry point. I'm going to write this line of code here. If dunder name equals string of dunder main. I'm not going to get into this too much, but what this does, notice when I execute the code with IPython, I have to specify, I have to target a file for IPython to run. I have to say, okay, run the code in this targeted file. What this line is saying is if this is the file being targeted by the IPython or by the Python interpreter, then run this code. Main, I'm going to write a function called main. Def main, just like any other function. It's not going to take in any arguments. Cool. For now, I'll just pass. So let's just write a factorial function in our lib here and import that into main, and then we'll run the factorial code in there. So the pattern that I like is before I define a function, I actually like to invoke it first. So let's say I want to print the factorial of 4. Okay. Now I'm going to do this thing where I run my code constantly, and it's because my experience has taught me to never trust code that hasn't been run, right? I'm fairly decent, I think maybe especially for being dyslexic, at like looking at code and catching errors visually, but I'm still pretty bad at it because I'm a human and I'm not a Python interpreter. If I were a Python interpreter, I'd be really good at telling whether code is valid or not. So luckily, I have a Python interpreter to tell me whether this code is valid or not. So what I'm going to do is I'm going to save this document, main.py. Notice it's not saved. Let's save that document. I'm going to do IPython 3 main.py. I'm going to run it. We're just doing a little check. Okay, so we get a name error. It says factorial is not defined. This is good. That's what I expected. So we better go define it. So I'm going to go into lib. I'm going to say def. Now, my whole goal right now is not to write a complete factorial function. It's just to get past this specific error. I'm going to say def factorial. It's going to take in a number. We'll just call it num. And print. Hi there. So my whole goal is just to get this to just work, just to be hooked up. If I see hi there, then I know that everything's wired up correctly, right? So that's my signal. So I'm going to save main, and I'm going to save lib, make sure all my files are saved. Then we're going to run it. Okay, right? So we actually get exactly the same error. It's kind of funny, right? I'm calling a function. It says it doesn't exist. I go in here. I define the function. Some of you may know what the problem is already. So what the problem is that I've defined this function in a different file, and this main file is not aware of that function existing in the other file. So we have to make it aware that the other file exists and has functions in it that we can consume. So to do that, so many of you have probably used import for other things. We can just say import. And we can just say the name of the file without the extension. You don't include the extension. In this case, just lib. So import lib. Notice that if I try to run my code right now, we're still going to get the same error and be like, hey, well, I should have fixed it, right? But our file is not saved. This was a lesson that I had to learn, a very obvious lesson of saving your files that I had to learn the hard way several times, several hours of frustrating work to such an obvious problem down the drain. Cool. Name factorial is still not defined. So the way we do this is we actually need to say lib.factorial. So we just imported lib. We didn't get factorial specifically. Oops. we didn't get factorial specifically. So we have to specify that we're calling the factorial function in this object in this file that we imported called lib. So we say lib factorial. Okay, so I'm going to save it and I'm going to run it. Okay, look, hi there. Look, I didn't get an error this time. I got hi there and I got none, right? We'll get to that none in a second here. Good. This is a good place to start. So, like I said, it's less about the code, more about the process that I use for debugging and working with this tool, what it's useful for. So I'll just write a factorial function. We'll do prod equals 1 for I in range 1 to prod plus 1 prod times equals I. Prod times equals I. And then we're just going to return that. Okay. Cool. So I'm going to save that. I noticed that main.py is saved, so if everything goes well, I should get 24. I got 1. Interesting. All right, so I did something silly. Very interesting. Somehow I got 1. Toby, do you see the probably very obvious mistake that I made? I see.
Oh,
I see.
Yeah.
Look at that obvious mistake. Did you see that?
I didn't see
Good old
it.
obvious mistake.
I didn't
All
see
right,
it
so-
because it was too obvious, actually.
Yeah, it was
happens.
so obvious. It eluded both of us.
Mm-hmm.
So you actually have to iterate through the right thing. Still, Python's not smart enough to know to predict which thing I meant. It just does the thing that I told it to do. All right, so both of my files are saved. Good, 24. That's the correct answer. Okay. So just a quick recap and we'll move on to some paracoding. This is the use case for VS Code. You're editing files and you can use a terminal outside of VS Code if you want. There's also this other tool up here. Some of you will have that Python extension installed. Some of you won't. I don't think it works on every operating system, but you have this little run button. And I didn't want to show this to you right away because I don't prefer to use it. I feel like it gives me less control, but we'll see here. Yeah, so I can hit this up here. And this is just gonna run whichever file that I'm in. Yeah, so whichever file I have selected, it's just gonna run that one. And that's a nice, useful thing. Like if you're just trying to wean yourself off of Replit, you can use that run button up there. If you want to take the next step, start trying to use your terminal for more and more things. Navigating and managing files is a great place to start with that. So, yeah, and you can see we just have a basic project with 2 files where we have our formal, and this is a pretty conventional way of constructing your entry point into your function. And obviously we would fill out main with all the logic for our problem, or for our program, excuse me. And we'd probably have more libraries if this were a real project, but that's a little teeny project in a nutshell. Do you have anything to add to that, Tovio, or does that seem fairly complete?
Oh, I think that's great. And a few people were a little lost at the beginning, which is really understandable. This is it's all new to a lot of you, and I think what Clark's showing here is a little bit past beginner, and so for beginners who are like first time looking at using VS Code. There's a couple people who have it installed locally or and haven't really opened it up yet. For those couple people, I'm going to start a Zoom meeting after, and we'll do some troubleshooting with them for after study hall. And they can share their screen, and we can try to walk through and have a few people just looking at trying to get it up and running initially, and then that'll be saved for people who are in the premium prep to see. Actually, we can probably make that available. We should be able to make that available to everyone now that I'm thinking about it. But yeah, that we'll just do that after study hall as well. I think this is an awesome walkthrough because it's about like the larger workflow, right? It's like you've got multiple files you're working in. You've got your driver, your main file, right? And then you're pulling in your other files. And I do this all the time. This is how I write code. You know, I have my project folder, I have the driver, and when I pull in other files, I separate them into, let's say, I've got my plotting functions in one file. I've got my text cleaning functions in another file. I've got, if there's a model that I'm building, I do that in another file completely separate. And then actually in my main file, I don't write any functions. The only function I might write is in the format that Clark has. I do something almost exactly like that, except I pull that main call onto the same line, like onto line 7. Like that's the only difference here, really, between the way that Clark's doing this and the way that I would do it.
Wait, just like this?
Yep, I do that.
Oh yeah, I do that too sometimes.
And you know,
that's nice.
It's not better or worse. It's just, you know, we all have our idiosyncrasies. Or if I've got procedural code to drive it, then I won't explicitly call the main function in the if name main. I'll put a little bit of procedural code below that, so that I can just run the file in the terminal, and it'll do all the work for me. It'll drive everything for me. But yeah, this sort of occupies a middle scope of skill, and we'll take a Zoom meeting. We'll make just a quick Zoom meeting for after study hall to kind of dig deeper into the rudiments of just running VS Code for the first time. Cool. Yeah. So let's switch over to Replit and continue where we left off last time. And Clark and I will. Actually, I'll run Replit from my machine if you want to stop sharing. And
okay, yeah, that'd be better.
And let me get out of full screen on here. There we go. There we go.
Zoom.
Yeah, Zoom. Zoom's a good time. So I'm gonna try to set this up really quick to be a little bit better. And
I'll be right back. I'm going to turn on the light. It's getting kind of dark in here.
Okay, sounds good. All right. Okay, so I've got VS Code open over here, and normally we would be able to, pair code here, but due to some limitations in VS Code on a virtual machine, we're going to forego that for today, and we're going to just explore some code using Replit. So I'm going to open up a Replit. And I'm just going to set it over here. I'm going to do a new REPL, Python, create REPL.
Are you sending that to me?
I will in a moment, yeah.
Okay.
And we're just going to work out of the main.py, so I'm not going to worry about the files here. And I'm going to back this off just a little bit to there. So I think, yeah, that looks okay. And to share, what I'm going to do is, well, I can't see it yet, but there's this share button. So I'm going to get this, and I can have up to a certain number of multiplayers, right? I'm going to copy this, and I'm going to Slack it to Clark. So REPL used to have unlimited multiplayers, and then they made it so that for the free version, you can only have one multiplayer. And due to the pandemic, they changed it to 50 because they figured people might really want to be pair coding. Okay, Clark, I just slacked that to you.
Alright,
And
grab that.
okay, so I think we're good. So we're gonna go back to the lessons in a moment. I want to answer a couple questions that are in the Slack thread. Let's see. Okay. Okay, Replit. I'll allow
Okay,
it.
Replit. Okay.
Oh, you know what? I'm not seeing any coding questions in here yet. I do see an environment question, but that's probably better handled one-on-one, so I'll leave that. There's a question, will we be going over the tic-tac-toe game? Got stumped on that. You know what? Why don't you Slack me a message to remind me to do that? I can do that in the next round. I would have to track down the problem, because it's not in our general learn materials. But it's the kind of thing that I'd be happy to maybe allocate the first 20 minutes of next study hall, and we can pick the problem apart. I'm not sure if this week. Well, I think this week I'm going to be doing a Sudoku stream, and Sudoku to me is a little bit more fun than tic-tac-toe, but maybe a little bit too high level. But we can start with tic-tac-toe maybe in the study hall on Wednesday, and then when I stream on Thursday, maybe we can do the full kind of Sudoku approach. Yes, there's study halls Monday, Wednesday, and starting this week, Friday as well. We're debating whether or not to also add in a Tuesday study hall. It kind of depends on our bandwidth, because we're going to be doing a lot of interviews soon. So, currently we can cover Monday, Wednesday, Friday, and these are being really well attended. So, we see a lot of utility here, and if we can make a Tuesday study hall happen as well, we'll do that. We'll do that too. Okay, there's a question on list iteration, the enumerate function challenge 3. So let's see. I think we're almost into. Oops. Let me just. We're almost into list iteration. So maybe. Actually, we're in list basics. Okay, yeah. Why don't we jump over to list iteration, enumerate function challenge 3, and then we'll come back to nested lists after that. And if you're, oh, notice Clark can type in here, and so can I. Right? So, yeah, we both have control in this space. Sometimes when you're pair coding, that's not what you do. Sometimes you have you just screen share, and you work on some code, and then you send it over to the other person, and they screen share their code with you. There are multiple ways that this exists. Replit's kind of nice in this regard, especially if you're new to Python, because you can both type into an editor and hit play, and that's it. Okay. So we're talking about the enumerate function, challenge 3. Let's take a look at this. And I might just make this a little bit smaller and bigger. Okay. So write a function called alt series. This function should have one parameter, which will be a list of numbers. And this function should, in a variable called alt sum together all the numbers in numList. Okay, so, ooh, it's double, what is happening there? Clark, are you seeing it doubling the function definition, or did you double it?
I did that on purpose because
Okay.
I'm a snide jerk who wants to type as little as possible.
Oh, awesome. Okay, I see what you mean. Okay, so
Yeah, I just wanted that function call in there.
yeah.
Okay.
Awesome. Okay,
So
so
def alt
go ahead.
series take what?
In a variable called alt sum, sum together all the numbers in the num list. Num list, it should be the parameter, a parameter to alt series.
LIST, right?
Yes.
Okay. So alt sum. Okay.
And alt sum, it should be in a variable called alt sum, sum together all the numbers in num list, where the values with even indices are added and the values with odd indices are subtracted.
Even. So I'm just gonna do this. So I'm just using this comment as a note to myself for what this should be. Okay. Shall I?
Yeah.
Okay.
There are a couple more things that you'll want to do in that enumerate, or in the loopage in where you enumerate. But
right.
We'll get to those after. Maybe we'll just do alt sum first, and then we'll do the others. There's another one that's power sum, and another one
that's how I prefer to work anyways.
Awesome.
Is to work incrementally, right?
Yep.
Get one bit working at a time. Okay, cool. Okay, so here's my test data. I personally have a rule of like never work on code that you can't execute easily, right? So I'm doing this and just building up a little test for myself so that I can, and Tovio's doing the same. He's writing some tests here so that we can see the output of this function as I run it. And as you'll see, I'm going to run it quite a lot. So. All right. I want to have a return too. What do I want to return?
So you're going to return 3 variables, alt sum, pow sum, and idx sum. So I guess we'll just start with alt sum.
Yeah.
We might as well initialize all of them.
Yeah, I'm just gonna do this actually for now. We'll just comment those out and get to them bit by bit.
Yep.
Let's do that. All right, so alt sum is sum of even values and subtract the odds. So for I, L,
and in this case, I just means index and L means element.
Let's call it IDX.
Sure, yeah.
And should I call it? Yeah, I like EL.
EL is fine. Yeah, we know what it is.
So for IDX and L and enumerate nonlist, the reason I'm doing IDX is to be able to tell whether I'm on an even or an odd,
index.
Index. Yeah, so I can. And I want the index to start at 1, don't
I? I don't think so. I think you want it to start at 0.
Oh, okay. I thought I did a similar problem where it specified that specifically. But that's okay. Perhaps it was
I am sorry.
Similar, but a different.
You are correct. It does start at 1. Yeah, I didn't see that further down, but it is.
I think I helped somebody with this the other day. It started at 1. Okay. So for IDX and L and enumerate numlist started at 1. I'm just going to print IDX and L. This is what I always do when I write a loop. Cool. We got an arrow. See, this is why I do this. This is exactly why I do this. I said I took in num list with an I and I passed num list without an I. And usually in my own variables, I don't use the I. But... All right. Good. That looks like it. All right. So we'll say I want to be able to see if is IDX even or odd. So we'll say if idx mod 2 equals 0, then I know it's even. IDX is even. Oops. If IDX mod 2 is 0, alt sum plus equals element. Else IDX is false, or is false, is odd. Alt sum minus equals element. Cool. All right. So that looks good to me. Just to be clear here too, I don't usually put in the comments like this. I'm just doing that for today, so you guys can see what my intention is with these lines. Cool. All right, what do you say next, Navigator?
Oh, do you want to run that really quick and make sure we're getting the right value for the
Awesome.
alt sum?
Yep.
Okay, that looks good, right? And if you look at these values down here, right, we expect a tuple where the first value is 4 in that first instance, and the second value is 0. Actually, for the my list that gets passed in on this line 17, we don't have the values for that, but we can see the other two are working, and I think it's a safe assumption that this first one is working as well. Okay, cool. So the next thing is the Pow Sum, and in a variable called Pow Sum, sum together the result of raising each value to the power of its index.
Okay, so value to so L to I, right?
Yes. Yep.
Okay, so Pow Sum. It's the sum of.
It's the sum of the elements raised to their indices.
I gotcha. Cool. Okay, raised to the IDX. Of course, we got to make Pow Sum exist. Of course, I'm not returning it. Okay, 4, 3, 3, 0, and 4, 4, 3, 3, 0, and 4.
Yep.
So, yep, we can confirm that the outputs match our targets.
Mm-hmm.
Good.
And
what's next?
Just a quick aside here. So what we're doing is sort of a manual visual verification of a test, right? We're not writing an actual unit test. That's something that we don't really get into in our course materials, but that's definitely something that you see in our course materials. Every time you run a challenge, it's running it against a bunch of unit tests that we've created to automate the testing. And that's a standard practice across everything, across all development. There's something called test-driven development, and in general, you write your test before you write your code. And so you know what to expect from your function, and if your function works as you expect, then you know that your code is running correctly, right? Or that it's written fairly well. Of course, that doesn't take into account optimizing your code for runtime or anything like that, but it's something that leads to less errors, right? Because you can see offhand with these unit tests that not only is your function doing what you expect it to do, it's not doing what you don't want it to do, which tends to be as important.
There are also 2 other immense benefits to it. One, once you get used to it, it is very easy. Like the cognitive load, the things that you have to think about reduces like kind of tremendously. When I got into it, I was like, oh my gosh, like programming was like this hard, challenging, brainy thing that always like made my brain hurt. And then I started I started writing like my expectations, even just these simple visual tests. And it like the amount of work that I felt like I had to do to get running code was just went down like, I don't know, by a tenth or something, it felt like. But it involves committing to just doing this work before you start solving the problem. And I notice for a lot of people, like a lot of people really want to just jump in and start, getting into this part where they're like writing this loop and the conditions, and they don't even have the variables created. And it's like, well, you intend to create those, but once you're 3 variables deep that don't exist, then it can be a lot of cognitive load to remember all of that to get the code working again. So that's one thing, is it makes coding very easy once you get used to it. The other thing is that it makes it very fast. Like, in addition to making it easier, I don't know, in my experience, and I've worked with a lot of other people with this very thing, doing these light tests, just these visual tests like this. And I think others would attest that the speed at which you can produce code just goes up pretty dramatically. So.
Oh yeah, and the other thing with actual like committed unit testing, your unit tests become your primary documentation for how the code functions.
Right.
And that may not seem obvious, but if you've ever inherited anyone else's code, you didn't write it, it's basically unreadable to you. But if you can look at some tests, you're like, oh, well, I can see what this is supposed to do. I may not know how it does it, but I can see what it's supposed to do, what we expect it to do. And so I can figure out, given time, what it's actually doing. So Clark already wrote this code, but the IDX sum is meant to sum together the result of raising each index to the power of the value at that index, and that's what we're seeing. So the index to the value, right? And that's just incrementing that. So this looks like it should be working code. Let's see if this runs in Learn. So let's see if we pass all the unit tests.
We'll see.
We'll see. And there's a chance that we won't, and that could be, in general, that's going to be just an issue with the code. Every once in a while, we do have a unit test issue where something that should work doesn't, or something that shouldn't work does. That does happen from time to time. But if you let us know, we correct it as soon as we can. So that worked, right? It ran 2 tests, and those came out okay. And then we give you, essentially we give you this is almost the exact same thing. No, this is the exact same thing as what was written here. And you'll see that happens.
Really? It was exactly the same as the example?
But with different names, with different, instead of using IDX comma EL, it used IDX comma val, right? So, and it's funny, like all of us use different things here. Like my tendency, if I'm using Enumerate, is to use IDX, although in other cases I would use I. If I wasn't using Enumerate, instead of EL, I would probably use item, or I would use val, like we're seeing above. Or depending, I would use num. So all of those are valid ways, and none of them is better or worse than the other. So hopefully that helped. That walkthrough helped. Yeah, cool. Let's see.
You want to do another one?
Yeah, let's do another one. And we might take up the time today, not going through the lessons, but if we're helping get people unstuck, that's that has high value. So, okay, I think this one. Okay, I've been hung up on open-ended problems challenge 2 under the while loop section. So let's track that down. Under while loops, open-ended problems. So both Clark and I think, have a lot of opinions on while loops, and we'll try to curb that a little bit. But yeah, just a little bit. Just know that it's, how do I say this? Know that you tend to want to avoid while loops, and we put lessons in here because we put this while loop section in there, unit in there, because while loops are foundational in basically all programming languages. And in most programming languages, you learn while loops before you use for loops. And it's because a for loop, you can imagine, is a more constrained while loop, right? Any logic that you can perform with a for loop, you can perform with a while loop. And that's just...
but worse.
Yeah, but worse. The thing about Python is Python's while loops, they tend to have some kind of computation overhead, and I think this comes down to I think it's a look ahead issue in how Python processes things, because in general, for loops will if a for loop doesn't have loops that are dependent upon each other on the processor level, then it can run the different iterations of the for loop sort of uniquely from each other, right? And it can make a prediction on a few of those iterations even when they are dependent. Whereas I think in Python, the issue is that a while loop doesn't really do good look ahead for the next iteration. Maybe this is like
it can't, right? Like it just
right.
Like by its by its logical nature, it must not.
Yeah, and I think there's a potential for, like, on a computer organization level, to do some look ahead with a while loop, because at the end of the day, a while loop and a for loop are essentially the same, and it's really a pre-compilation issue. But I think for whatever reason, Python does not have very optimized while loops. And if you play around on Code Wars, or even in some of the while loops problems on Learn, your code will time out, and that's because the while loop is just taking its time. Sometimes it's because you have an infinite loop, but while loops just tend to have a lot of overhead. And this is something you're going to see in Python as you go. Some data structures and some programming constructs really do work faster than others. Like, if right now we're using lists all the time, but you're going to find that when you get away from lists and you use dictionaries, dictionaries are just blindingly fast in comparison to lists. And then when you get into pandas, what you're going to find is pandas is blindingly fast in comparison to dictionaries. And then when you get into NumPy and you're dealing with NumPy arrays as opposed to pandas data frames, you're going to find that NumPy arrays are faster, maybe not blindingly faster than pandas data frames, because data frames are actually built essentially out of NumPy arrays under the hood. But the more complex data structures that are optimized are going to be where you put your focus and your time. However, with the built-in language, you just sort of have to get used to some of the operations and computation overhead of, like, say, lists. Lists are pretty slow, but we don't notice that slowness until we're trying to handle more computationally complex problems, you could say. Okay, that's... I could have TLDR'd that, and I didn't. So let's move on to... I've been hung up on open-ended problems, challenge 2 under the while loop section. So this is complete the function called next prime. This function takes a single parameter called num and returns the first prime number larger than it. Note that this function only takes positive numbers. So I'll go ahead and do this one. I really like this problem, or this kind of problem, where you're given a value, and theoretically you don't really know where the next value is going to be, right? So if we put in a number, we want to go up from that number until we find the next prime, right? And
you want me to write an isPrime function for you while you write this one?
Oh yeah, please. So yeah, actually, Clark, why don't you code out the isPrime function, and we'll sort of talk about that. So we're gonna write, or I'm assuming Clark's gonna write a very simple isPrime function here, where we don't optimize it, right? And essentially, let's see. Returns the first part. Yeah. Okay. Okay. Yeah. So if the number is less than 2, we're gonna assume that the number is. We're not going to define it as being prime or divisible by any other number. And then we're just going to say, well, everything between 2 and the number, if the number itself is divisible by any of those divisors, then we know it's not prime, right? So it's a pretty simple test for primeness. We could optimize it by starting at, for example, 3, and only looking at odd numbers from then on. And that trims down the number of items we check. We can also go up to half plus 1 of the number, so we can trim the upper range as well to get a slightly better is prime function. But this is the logic fundamentally, right? So if the number is less than 2, we return false, and then we just check for divisor and range from 2 to num. If any of those divisors go into num evenly, right? We can check that with modulo. Then we know it's not prime, and that's fine.
I never thought to do that, right? You could start it at 3, and then go in steps of 2. That's really good.
Yeah,
but then do you have to add a special case for
even numbers?
Well, what if num is 2?
Oh yeah. Also, if num is 2, return true. Yep.
Equals 2. That should be it. There's a couple optimizations there, right?
Yeah, that should work. That should work. Sometimes I
variation. Oh, what's that?
Sometimes I fumble on this, but yeah, let's just check all the numbers between 1 and 200 or something, and or 1 and 100.
1 and 11.
Yeah, that sounds good.
Yeah. Because those ones I know I can kind of look at and be like, okay, that's prime. That's not prime. Let's do negative. Let's do negative 5 and 11. There you go. Is prime. No.
Cool.
Is that going to do it?
Indentation error.
No.
Where's that? There.
You get it?
Maybe.
Oh. There it is.
Oh, okay.
Next prime.
Awesome.
Next
okay.
prime needed a pass on it.
Cast this to int.
Oh, yes.
I'll just expand this a little bit.
You can floor divide here, right?
Oh, yes.
Okay. That's what I meant. Yeah, that's what I meant to do. Good. All right, so everything less than starting at 1 and below is false. That's what we wanted. We wanted 2 and 3 to be
but what
true.
about 4?
4 is not a prime, so that's a problem. So why is 4 a prime?
Let me think about that. It's just a prime. Go ahead.
Look, 8 is also a prime here.
Yeah. We're gonna return true for any evens that are evenly divisible. So we can just do this.
Right.
If num modulo 2 is 0, then return false. So that limits our space. Yeah, I thought that that was going to be an issue. So let's just run that again. And now 4 is not a prime, 8 is not a prime, 10 is not a prime. Let's. I think this should be functioning. This should be fine because we're checking everything else,
I think
right?
so.
Yeah. Okay.
I'm going to combine into an OR with the first one. Right there. Right?
Yep.
If it's less than 2 or divisible by 2.
Yeah. That's because there are going to be a lot of numbers where that is the case. Okay, so I'm going to go ahead and comment out this print that we're doing here, and let's consider the logic for finding the next prime. So we put in a num, and we can pretty much say, well, let's start at the num, and let's say to check, and this is going to get num plus 1. And there's a number of ways that you could go about this logic. So, you know, there's more than one valid answer here. And I'm going to say while is prime of the num to check is false, then we're going to increment the num to check. Right? Plus gets 1. Okay, is that the right logic? And then we can just return the num to check. Does that seem like it's going to work out? I think it is, but you know what? Let's just check it out. So the next prime of 11, right? We would expect this to be 13. And yeah, so let's run that. And it is. Okay, so what about 13? What do we expect next? 17. Let's do 29. Not 129, but 29. Okay, okay, these are looking like prime numbers. So why don't we do this? Why don't we make a list of prime numbers here, and we'll say there we go. For num in range, let's do 2 through 1,000, and let's just say if is prime of the num is true. Now I don't actually need to do the double equals true here because that's enough of a condition right there. Let's print that. Let's print that num. So this is going to give us a list of prime numbers, and I'm just going to snag that just as a reference. So you know what? Let me throw that into a list called primes, and I'll do primes.append, and I'll append the num, and then I'll just print the primes and screenshot it really quick so that we can see it kind of all in one place. Oh, it's all the way at the bottom. A REPL process died unexpectedly. Great. Okay. Okay, REPL.
It's because it's such a good environment. That's
yeah.
why.
I mean, I like REPL a lot, you know, and
I do too. Yeah,
I think if it didn't have certain like performance issues, it would be perfect for a lot of things. But it's also a great, you know, gateway into just coding in general. Like it's kind of an amazing thing that they're doing. Anyway, so here's our list of primes, and I'll go ahead and comment all that out. And why don't we just check some numbers? So if I put in 607, we should expect 613, right? And let's just say 613. Okay, what is happening there?
613, I see it.
Oh, did it output? Yeah, it didn't output for me. That's the other thing about REPL. From time to time, it just crashes.
Yeah.
Okay, you know what? I'm gonna refresh this and hope for the best. Hopefully, I didn't kick you off,
Yeah.
Clark.
Who knows?
Yeah, that's a thing that definitely happens. Okay, so 6.
Yeah.
Okay, yeah. So we see 613, and we could test this with all the primes and make something more rigorous, right? If we want to, but we don't really need to. And you know, so why don't we just grab this code? We'll just make sure it works. We'll make sure that it passes tests in Learn by just running it. So this is kind of a nice workflow, right? You work in a code editor, and you try to make sure that it works, right? And then you paste it into Learn. That tends to be a good way to go about this. So all of this is pasted in. Let's see if it works. Does it pass the tests? And it does. Notice that the next prime that we have here in potential solutions is different, right? This looks different. While true, we're actually using a Boolean flag here, and we're saying is prime gets true, num plus gets 1, and we're performing an internal loop here, right, where this is essentially the functionality of that is prime function. Like this is fine. This is another way to do it. Personally, I like to break out functionality into their own functions, and atomize, right? So we've got an is prime function, then we've got a next prime function, and even by the names we know what those mean. So that's that problem. And let's see. Okay. So I'm going down the thread. Let's see if there's okay. Somebody's asking on while loops open-ended problems 3. So why don't we take a look at that too? I'm sorry if I missed anyone's question. I'm scrolling back up to see, but I don't think we did. If we did miss your question, go ahead and put it in again into the thread. We're working on open-ended problems 3, which is about the 5th message up right now. Okay. Oh, somebody said that we definitely need to move the Clark. Oh, that makes sense. Sorry about that. Here, why don't I do that now? I'll do this since we're not. Or here, we'll do this. Okay, that works.
Is that better? Hopefully it is.
Okay. So let's look at open-ended challenge 3. All right. So complete the function to the following specifications, and this is one of those times where you're going to be writing based on a docstring. And why don't we just take a look at this docstring, and I'll try to make sure that I don't. Okay. Yeah, that looks like it'll work. All right. So the twin prime conjecture is a theory in which there are an infinite number of pairs of primes that differ by 2. This function finds the nth twin prime pair. For example, the 5th twin prime pair is 2931. Woo, this is a cool problem. Yeah, this is gonna be a tricky problem. I haven't written this before. So twin primes conjecture is a theory in which there are an infinite number of pairs of primes that differ by 2. This function finds the nth twin prime pair. So why don't we grab a couple of these? We can grab these prior functions that were written. They're still going to be applicable. And we'll just use these as dependent functions here. So we still have is prime, and then we have next prime. Okay? Oh yeah, and why don't we, since you probably missed a little bit of the code, why don't we just paste this in to the Slack? And I'll just do that really quick. Sorry about covering up the code. That's something that happens a lot when I'm streaming. Unfortunately, I try to catch it. But thanks for pointing it out. Sorry we didn't recognize you pointing it out earlier. Okay, so, right. So first we check if the value is prime, and then we go while is prime, num to check, right? And we increment by 1, and ultimately we are checking all the primes, right? We could do an increment by 2 to save a little bit of time, right? Because next prime, aside from 2 to 3, there are no primes that are 1 away from each other, right? But that's okay. This totally is. This is good. This works, and we can go from there. Okay, so twin prime function, infinite number of pairs of primes that differ by 2. The 5th twin prime pair. Okay, so where I would start with this is I would just think about this as being a collector, right? Where I would say twin primes, and just start this off with a list. And I'm gonna, not twim, but twin. And my logic here is going to be something to the effect of if a number is if a prime number minus its next prime equals 2, then those two numbers constitute a twin prime pair. How about that? So if I'm just thinking in a boneheaded way, maybe I can start at 0, right? And I can reduce values from, well, let's see. We're looking for the nth, right? So we could actually use a for loop here. No, we can't. We shouldn't. Okay, this is an open-ended problem. Cool. Okay, so while let's call this the twin prime counter is I think I'm going to do a while true here. It's that kind of problem, I think. Although we could probably find a mathematical form for determining an upper end so that we don't use a for loop. But, you know, I think this is going to be fine. So I'm going to make something called twin prime counter. And I'm going to start at num to check. And I'll start this at yeah, so when we're thinking about the twin prime, the first twin prime that we're considering is the 3 and 5 pair, right? That's our first one. So our twin prime counter will start at 1, and we're going to try to test this so that, or we're going to try to make this so that it recognizes the first twin prime as being 3, 5. So I'm going to say the num to check, we're going to start at 2. And we'll say if actually, Clark, do you think we should just reduce this from a list of primes? It's kind of a tricky problem, isn't it?
Apologies, I was taking care of some Slack questions.
Okay.
I need to catch up to speed here.
No worries, no worries. I think let's just try this. Let's say num to check. I think we need an internal for loop here. Yeah, this is kind of it's an interesting problem. It's kind of tricky. And this is kind of a nice, here, Clark, why don't you take a look at this doc string and give me your opinion about how we should proceed with it.
21 through 31 here?
Yes, 21 through 31. Yeah, and I think this is the kind of problem where I'm looking at it and I would probably write it down on paper and then think about how I would do this, how I'm thinking about doing it, right? Because the way I'm thinking about it is we find a prime, then we find the next prime, and if the next prime minus the prime equals 2, then we append it to a list of primes, of twin primes, right? So just me describing it out loud right there, that is the logic, right? And you want to get used to this kind of describing it to yourself, and sometimes writing it down in a very, in that way. So why don't I just write that down?
what about having a like an is twin function, helper function? That kind of occurs to me. I'm not sure. I mean, that's just what occurs to me. Just like have something that would,
yeah, why not?
Yeah, so you find
yeah.
the next two, but then I guess you still got to find the next two primes, plug them in there, and then it just tells you if the numbers are 2 apart. So I don't know.
So all we have to do for the is twin prime function is say if we need a num1 and a num2, right?
Yep, exactly. Yep.
Yeah.
See, all it's doing is its job is so trivial. It's not even almost worth.
Yeah.
Right?
Well, let's just do it anyway. If
yeah. Okay.
if num2 minus num1 minus num. I should do num_2, shouldn't I? I don't know.
Yeah, num_1 as well.
Yeah, why don't we do that?
Yeah.
And we're going to assume here that num2 is greater than num1. Num2 should be the next prime. Or we could do, why don't we do, yeah, okay, we'll just do that. If that equals 2, then return true, right? And then else return false. Okay. I mean, sometimes this is really a helpful way to go, though, honestly. Like, we're like, okay, well, we can take a number and a next number, and we can do something like that. So, so why don't we say, all right, so num to check. Num to check is 2, so let's say, sorry.
Wait a second. I just thought of a wild idea. Nope, that won't work. Nope.
So is twin prime of num to check, comma, next prime of num to check. And here's a cool thing. Why don't we just take this out of here, and let's just call this next. Oh, we can't use next. Let's do next next prime underscore. Next prime val, let's call it that, and then
next prime.
let's take this next prime val, and we'll first get the we'll first get that, and this is a little bit of redundancy, but that's okay. So we'll get the next prime value, and then we'll check is twin prime, and we say, well, if is twin prime, if this returns true, then we can just append it to twin primes, right? And twin primes dot append the the num to check.
And don't you want to only do this if you're sure that num to check is prime?
Well, we're always going to start at 2, so it's going to be fine. We're gonna go all the way up. And that's going to be fine. It's not going to be optimal, but that's okay.
That's interesting, though, because you're feeding num to check. Like, I mean, is twin prime, it's counting on both of its arguments, I think, being primes, right?
Yes, but that's okay, because we're going to be able to count on them being prime. Because
will
we will. Yeah, no, check it out. We're getting there. We're getting there. So let's.
Okay.
So
that's what I'm thinking about. Well, I'll let you do it. I'll let you work your magic.
Okay. So we're getting the next prime value. We know that 2 is prime, and that's the initial num to check. So we're going to get 2, and then next prime value is going to be 3, and then we're going to say if is twin prime of 2 comma 3. That's not true, right? So that's going to be false. So we won't run this line 53, but then we're going to alter num to check.
Right.
We're going to take this and we're going to overwrite it with the next prime val. Right?
Right.
And we're also, let's see, the twin prime counter needs to be incremented, right? So maybe what we can do, and this is kind of the tricky thing, we only increment the twin prime counter if twin prime counter is incremented, right? And so we'll just go twin prime counter plus gets 1. And then we ask, well, is the twin prime counter equal to, what is it, to nth, right? If that is equal, then we return. I mean, we don't even need the collector, honestly. We can just return this tuple. Right? Yes. So why don't I delete the collector? Because we don't need it. I'm not going to do the append here. I can just
get rid of it, right?
I can just get rid of that.
Yeah.
Okay, so I think the logic here is sound. We increase the counter. No, there's something a little off here. Because 3 and 5 is going to return as 2. So why don't we set the twin prime counter to 0? Okay. So let's test this. Let's test this with, oh gosh, twin prime of 5. Let's just do the 5th potential twin prime. Let's see if this works. My suspicion is we're going to get an error here for some reason. Oh. Okay. Why don't we... okay, why don't we do this? Why don't we say for
okay.
I in range, and let's go up to the... Let's do the first 20. Is that a lot? I'm not actually sure. Let's do twin prime of I. Let's see what these twin primes are.
We're doing the same thing in a different way. I should just leave your code alone. I'm so
no, you're
curious.
Good. Yeah. Let's find out. Oh gosh. Okay. Is it printing on your end? I think I'm gonna have to reload the window.
It's running. It's still running. I think it's.
Let's change that.
Yeah, let's do that. I think we're gonna get an email from the good people at Replit.
Yeah. Why don't we do this?
Yeah, let's go. I think Replit has crashed.
Okay, I'm gonna reload the window. Yeah, again, this is like a downside of using REPL. It crashes, and it doesn't.
Often.
It crashes often enough. Yes, it crashes often enough. Okay, so let's see. Did it hold on to? Yeah, it held on to our values. Sometimes it won't save if you reload the window, which is a little frustrating. But, huh. Let's see. We might have an infinite loop here. Let's see. Yeah. Oh, yeah, just move that down. Okay, that's looking pretty infinite to me. It's weird though, because it worked on the first try, so we must have changed something somewhere along the way. Next prime val gets next prime num to check. If is twin prime. And then we are of num to check next prime val. If the twin prime counter equals the nth. Oh, okay. I see the issue. Yeah, we act. Okay, let's go ahead and run that again. Still? All right. Maybe somebody is able to diagnose our error here. Let's see. Okay, so that's working. Let's see if it works for the first value, which should be 3 and 5. Okay, it's not working for 3 and 5. That's the issue. So there's a couple ways we could solve this. We could, and I don't think this is the worst plan. Why don't we say if if nth equals 1, then let's just return 3 comma 5. And let's see if it works for the second value if we do this. So that gets 3 comma 5. That makes sense. Let's look for the second value. Okay. All right. So maybe what we should do I mean, this logic is so close. Let's just see. 5, 7. Okay. And the third value, 11, 13. Okay, this looks like it's working. 17, 19. These all look like twin primes, and they look like they're in the order where we'd expect them. 29, 31. Okay, I think this is working. Yeah, let's do that. So Clark is gonna print out our first 5. Okay. Is the function name correct? Twin prime. Yep. All right, so let's pare this code down a little bit and just make sure that it's doing what we expect in the way we expect. So we have the twin prime counter. We started at 0. The first thing we check is this num to check. And then we say if nth is 1, then we return 3 comma 5. And that just gets rid of a base case that is hard to prime for, no pun intended. And while true, we get the next prime, and then subsequently we keep replacing the num to check with the next prime, and so we're always comparing the next 2 primes. So why don't we we need all of these functions, as it turns out. So I'm going to paste all of these in, and let's see if that passes. Oh, it failed. Oh, you know what? It's supposed to return a... I'm returning a tuple here. We should be returning a list.
Let me just voice my opinion on that, which is, ugh.
Yeah, I expect this kind of function to return a tuple.
Yeah.
Oh. Okay. Huh.
Didn't do it?
Maybe it just didn't register. It's saying, oh, I see why, because 3 comma 5. So I still have that in as a tuple. I just have to change that. Okay, so let's find out. Yep. So this works. This works. This is cool. I didn't know we had this problem in here. We have all these new problems that we authored over the last 3 weeks, 4 weeks. So cool. All right. There's a question in here. What about using infinite generators offset by 2? Yes. I mean, yeah. So we took this very brute force approach, right, with our is prime. There's a much more... We can optimize is prime, but we're not going to worry about that here. There's a nice non-generator solution for an optimal is prime that I came across. I think it's the most performant form of the function that I've seen. I might try to dig that up. But it's really just sort of optimizing in a way that looks very much like this. It's not much more optimal than what we're seeing here. I mean, if it's a generator, that's great. Oh, yeah, why don't we just... I'll drop this in. This is this solution is different from the example solution when you solve it in Learn. Just so you know. And your coding style, like I tend to atomize things quite a bit, like what we've done here. But that's partially a code style thing. It's not necessarily right or wrong. Okay, so I'm gonna just scroll up and see.
Now all we have to do left is combine this all into one function and one comprehension that exists on one and only one line. Actually, not even in a function, in a lambda, using only single letter variable and parameter names.
Yeah.
And then we'll be good programmers. Then only then will we have done it correctly. No, I'm joking about that. You shouldn't do that.
Yeah, it's interesting. I mean, I love comprehensions, and I love
Me too.
really slick little 1-line and 2-line solutions. And I do that in my own code to some degree, but it's really about explainability. Like if I'm handing something off to somebody, I won't write an unexplainable function in general. But comprehensions, once you get used to them, are very explainable. We didn't do any here. I'm trying to think where we could have in here. We could, but it just wouldn't actually be helpful in here. I think all of this looks best served by what we've done. I mean, I would rewrite these so they're not using while loops. I would use for loops with arbitrarily high values for the range, but that's neither here nor there. I just prefer doing that to while loops, but I'm not going to show you that here because it's not necessarily a good habit. It's just what I do, and it's a choice that I make, and it probably frustrates a lot of people when they read my code. So use a while loop for open-ended problems, even if you can use a for loop. Let's see. I'm just scrolling to see if there are further questions. Awesome. Okay. Get some semicolons in there. Okay, so we've got about 10 minutes, and let's just jump back to nested lists. I'm going to talk about nested lists. So this is sort of like a big rewind on the level of difficulty that we've been discussing. Oops. Let me just make that a bit smaller. And I'm going to go ahead and delete all the code out of here, Clark.
Go ahead.
Cool. And this is going to be a simpler concept for people who are, newer. We do want to go end-to-end on the materials, but answering questions is more important than going end-to-end on Learn. So that's why we're focusing on people's questions. Really, we're talking about nested lists. So the objective of this section, and maybe I'll just copy it and put it into the Slack in case you want to open it up. The objective of this is create a nested list, access an element from within a nested list. So this is pretty straightforward. And maybe I'll demo it with a problem that we've asked people to do in the past. Okay, first I'll just talk about it. So let's say we have a list, right? So some list, and maybe I'll make this a little bit bigger and pull it over. Do that. Make sure it's still visible. Okay, that looks fine. So we've got a list, and let me just put in some values. I'll mash some keys and just put a bunch of commas in there, and we've got a list. Okay, so if I want to access a value in this list, we already know how to do that. Whatever the index is, whatever the position is, -1. So this is the first position, which is index 0. Python is 0 indexed. If I want to get that first element, I can print list sub 0, right? And that's going to get us the first element. Right? Easy. Now, what if we have a list that contains other lists? And notice it's as easy as doing that. So we've got this initial list with 1, 2, 3, 4, 5, and then we've got all these other elements. So first off, let's just print the length of the list, right? Let's just see how long this is now. So it's 9 long, which is 1, 2, 3, 4, 5, 6, 7, 8, and we count this inner list as one element. So that's 9 elements. So what if we want to access something in this nested list? That's what we call this. We call this nested. It's just something inside of something else, right? Nested. If we want to access something in this, the first thing we want to consider is that this is the first element, right? This is the first element. So we want to access that first. And if I print this right now, you'll see that there's an error because why? Open, close. Oh, that's why. All right. So if I print this now, we get a list. We get this inner element output. So how do we access something in here? Well, we can just put a second sub in here, right? And let's get the third element, which is going to be 3, which is at index 2. And if I print this out, it's 3. Now, what if these elements in here are another nested list? Well, this is going to be 0, 1, 2 to access that. And notice now we're going to print out 3, 4, 5. What if we want to get the first element of that list? Well, we just do this, right? And, at some point this gets a little cumbersome, right? You nested and nested and nested lists. That's not very much fun. And so you kind of want to avoid it. There are better data structures to do this kind of thing, but you do want to expect to see lists of lists. You're more rarely going to see lists of lists of lists. That's a bit, that gets a bit clumsy. So let's see if there's anything else in here. No, this looks good. Okay, cool. So, in the next unit, we're talking about manipulating lists. And I know we've done a lot of that already today, but we kind of want to consider, we have this data structure called a list. We can create them, we can fill them with data, and we can traverse them, we can iterate over them. And we took a pedagogical choice here of introducing the data structure, manipulating the data structure without iteration, and then in the unit after manipulating lists, we iterate over lists, okay? And that's where we introduce for loops and everything like that. In this case, if you can get away with not using a for loop, if you can manipulate a list directly without looping on it, that's better than looping on it, okay? Now, when I say that, we're really just considering, first off, appending to a list and extending a list, which are pretty straightforward concepts, which we can talk about just kind of immediately, right? So the first thing that we want to consider, though, I'm just going to make this more of a kind of standard list right here. So we've got this list of values, and if we want to access something in it, we know how to do that. We just access it by its index, right? So this is, right, print list sub 2. That should get us 9 because 2 is the third element, is the index of the third element, right? So we can see that right there. Now, what if we want to change this? If we want to change this element, we can just access it, right, like this, and then we can throw something else in there, just like that. So list sub 2 is now going to be 7, and if I print this, we can see that it's 7. Something that I want to show you that, so can we do this in a print statement? Well, we already see that we can't. We can't do an assignment within a print statement. And notice expression cannot contain assignment is literally the syntax error. So if you see this error, this is indicating what it means, right? More often, you can do equivalence statements, right? You can ask the question, is the second element equal to 7, but you can't set the second element to 7 within this. You have to do this outside the print statement. So, yeah. And so if we run this, we get 7. And that's through simple assignment. Now, how do we add more items to a list? Well, we've modified the list sub 2. We've modified the third item. How can we put a new item on the end of the list? That's pretty easy. We can just do list.append something else. And this is, this is just a reminder that lists don't have to be all one type. They can be collections of any type. So we run this. Well, I'm not printing the list, but let me print it. So I'll just print the list, and we'll see that 687, etc., and the last element, this is new, is something else. So these are all, basic things that we can do, right? So let's make a second list, and we'll mash some more keys, and instead of appending, well, we'll still append, but we can also extend. And what this does is it takes list 2 and it takes all the elements and puts them in order at the end of list 1, or at the end of the initial list. So I can extend list by list 2. And then if I print list, we'll just see that now we've got everything that was in list 2. It still is. List 2 still exists and still has this stuff in it. But now all of that is in list as well, right? So that's pretty straightforward. These append is your bread and butter. Extend you're going to use from time to time. You're going to use append probably a lot more than extend, especially when you're running a collector, right? Extend is more when you're like smashing a few lists together in order to, do something specific. I'd say I write append 30 or 40 times more than I write extend. Just offhand, that's a guess. So all of this kind of leads into this idea that we can change lists. There's this concept of mutability, right? And a list, we can add and we can put new items in it. We can append new items to it. We can delete items from it. We can do all these things. And the list is still going to have the same position in memory. So if I, for example, run the identification of list, and I run this as we modify it, right? Then what I'm going to see is that this is the same ID. I am never changing the memory location of the object itself, and that may seem like a trivial or maybe esoteric thing to understand, but really what we're getting at is we can collect and we can discard from a list, but when we get down to it, that is still a list, and it's still the same list with the same namespace. That's the general concept of mutability, and next time we'll jump in at this lesson. So I'm just going to make a note that this is where we're going to pick up next time at list mutability on Wednesday. And as always, we'll take questions and probably spend more time answering questions than actually working through the lessons. We'll get through the lessons eventually, but we'll support with questions quite a bit so that you guys can see, just a bunch of live coding on the specific problems you're working on. So thanks so much. I'm going to post a Zoom link in just a couple minutes so that we can get into some nuts and bolts of VS Code. Less on the workflow side, but for a couple of you who are trying to use it for the first time, we'll just try to get a couple of you up and running. We'll kind of do it as we'll start off with the initial person who asked about it, about using VS Code, and we'll handle their request first, and then we'll try to address everybody, and hopefully we can get a few of you up and running with VS Code before the end of that. So yeah, thanks so much. We're going to sign off, and I'll post a Zoom link shortly